So we defined radical functions as the inverses of other functions. So at least if there's only one radical, they're always going to be one-to-one. Let's talk about how we take its inverse. I'm going to show you an example and put down the procedure as I work through this example. Let's let f of x be 2 times the 4th root x plus 2 minus 3. And let's find f inverse x. Now the first step is just like our first step in any inverse function problem. We're going to write y instead of f of x, and then we'll swap x and y. Alright, and now we're going to make this very common set of moves that we make, where we isolate the worst thing and then get rid of it. We're going to isolate the radical. So that means, in this case, that we're going to need to get rid of the minus 3 and the times 2. So I'm going to get rid of the minus 3 first by adding 3 to both sides. I'll get x plus 3 is 2 times the 4th root y plus 2. And then to get rid of the 2, we'll divide both sides by 2, and we'll get x plus 3 over 2 equals the 4th root y plus 2. We can just leave the left-hand side like this. That's fine. It's at this point that if we have an even radical, we want to make a note of the restriction on the domain. Right? The output of the even radical is always positive. So this quantity has to always be positive. X plus 3 over 2 greater than or equal to 0. Multiply both sides of this by 2. I get x plus 3 is greater than or equal to 0. Subtract 3 from both sides. I get x is greater than or equal to negative 3. This is my domain restriction in this example. Now, we're going to use the fact that if x is the nth root of y, that means the same as y being x to the n, to rewrite as a polynomial instead of a radical. If x plus 3 over 2 is the 4th root y plus 2, then x plus 3 over 2 to the 4th power is the same as y plus 2. And now we get y alone and bring back function notation. We subtract 2 from both sides, and we get y equals x plus 3 over 2 to the 4th minus 2. And then we write that as f inverse. F inverse of x equals x plus 3 over 2 to the 4th power minus 2. With the domain restriction, x is greater than or equal to negative 3. That's a lot of trouble to go to, right? But no individual step is terribly difficult. The two new things are finding the domain restriction if we have an even radical. If we have an odd radical, we don't need to worry about that. And then making this move to get rid of the radical. I'm going to give you one of these to try. Let g of x be the cube root of 2x plus 1, all minus 1. Find g inverse of x. Pause the video and try this now. Alright, so first I'm going to write y, and then swap x and y. Okay, and now I need to get the radical alone. All I need to do for that is to get rid of the 1, and I get x plus 1 is the cube root of 2y plus 1. Now this is the cube root. 3 is an odd number, So there's no domain restriction to worry about. I can go ahead and get rid of the radical. Saying x plus 1 is the cube root of 2y plus 1 is the same as saying 2y plus 1 is x plus 1 to the third. Alright, now I'll subtract 1 on both sides and divide both sides by 2. And finally, I'll bring back my function notation. My function's name is g. So g inverse of x is x plus 1 cubed minus 1 all over 2. I could simplify this, but I don't need to.